You have a quiz coming up on Wednesday of this week. On the quiz, you'll be asked to graph parabolas, ellipses, hyperbolas. You'll also be asked to write equations of parabolas, ellipses, hyperbolas. There are two sets of types of equations. Not here. There's two types of writing an equation that you might see. And the first is going to be that whole issue that we were talking about in our warm-up. If you're given general form for the conic section, can you write the equation? So we've actually already spent time in each section going through and grouping the x's together, grouping the y's together, completing the square, making it look like the standard form. So this part we've already really done. The key here is on the quiz, they're all going to be mixed together. So it would be helpful if you could identify which conic section it is. So that you know, like, do I want it to look like a parabola equation? Do I want it to look like a hyperbola equation? Those types of things. So we need to make a rule for parabolas, circles, ellipses, and hyperbolas. And I'm going to make, when we write these down, I'm going to write like one rule in our own words, and then maybe also try to address that general form that has those coefficients, A, C, D, E, and F. Think you got a question? No, they come in alphabetical order. You're concerned because there is no capital B. B, there is a term. It is BXY. And we currently don't have any conic sections that have an XY term. Because think about, if you had a term that was XY, would you group it with X's or would you group it with Y's? How would you factor out an X or a Y from that, right? Like that, and that's not part of completing the square. That's what comes after the quiz. We're going to rotate the conics with the XY terms. So, we'll get there. Okay, for a parabola, basically in our own words, we said we knew that very first equation was a parabola because it had x squared but not y squared. So I'd say x squared or y squared, not both. In my own words, I can quickly look at a equation and decide if it's a parabola based on that. If it's got an x squared and a y squared term, then I'm going to say it's a circle, ellipse, or hyperbola. Okay. In the general form, when you're looking at these letters for the coefficients, that would mean either A or C is equal to 0. Okay, A equals 0 or C equals 0. One of them, those coefficients to the x squared or the y squared must be equal to 0. What can we say about the x squared and y squared terms for a circle? Thinking back to your warm-up. What must be true about their coefficients? They must be the same, right? To be perfectly round, we have to have the same coefficient. So x squared and y squared have same coefficients. And what that would mean is if you were looking at your x squared and your y squared in the general form up at the top, that would mean that A was equal to C. Whatever your coefficient was for x squared, that's the same thing you have for C squared. And that's like exactly the same, right? They have to be the same number, they have to be the same sign. Okay, they're exactly the same coefficients. For an ellipse and a hyperbola, okay, mainly for an ellipse, we don't want it to be a circle anymore, so what must be true about the coefficients? They must be different, but so it's not a hyperbola, they still have to have the same sign. Okay, so key piece here is if it's an ellipse, the x squared and y squared have different coefficients, but they have the same sign coefficient. Okay, so I'm going to say x squared and y squared are not the same. coefficients, or do not have the same coefficients, I should say. Do not have the same coefficients. But they do have the same sign. Okay, that's really important. The only one that would have different signs will be our last guy, our hyperbola. In terms of what that means for A and C, we know that they're not necessarily the same, they're not equal to each other. If you were to take things that have the same sign and multiply them together, their product will always be positive. So we could say here, if you were to multiply A times C, it will always be greater than 0. It won't be 0 because then it would be a parabola. Okay. And it would have to be greater than 0 because they're going to have the same signs. Positive, positive, negative, negative. Okay. And then down here for the hyperbola, we'd say something like the coefficients have different signs. Coefficients of x squared and y squared are different signs. One is positive, one is negative. And that would mean if I multiply them together, it will always be negative. A and C. So the product A times C is less than 0. Blake, you got a question? Yes, very good point. Thank you for asking that question. In a hyperbola, the number coefficient could really be like the same absolute value number, so they could both be 3, but one of them would be positive and one of them would be negative, automatically a hyperbola, not a circle. Okay, so great question. Yep. And you might have even seen that in, like, you know, the homework from last night. You might see that in your examples today or your homework today, where a hyperbola could have that same value coefficient, but different signs. So then it's really not the same. 3 and negative 3 are not the same. Any other questions that you'd like to ask about that? Okay, next thing we're going to do is run through a quick example of what you'll be doing in your small groups here momentarily. Okay, and that is, I'm going to skip these 2 slides where we go over the equations. That is writing the equation based on some information. This is very much like what we did in 10-2 day 2. So we did 2 days of parabolas, one before the Easter break and one right when we came back from Easter break, right before your ACT. So this made me feel like a long time ago. But one section was about graphing, and then the other section was about writing the equation of a parabola given some information. This is different than writing the equation of like things that look like the last slide. We're not just going to group x's and group y's and complete squares and things like that. We've got to come up with what are all those things that go into the equation, or what is the equation that I want to use. So we want to write the equation of an ellipse with vertices at 1, -9 and 1, 5, and endpoints of the minor axis at 6, -2 and -4, -2. First thing I said back in that day with the parabola is sketch what you know. Okay, picture is going to be worth 1,000 thoughts here. Okay. Draw yourself a picture of what this ellipse looks like. Has vertices at 1, -9 and 1, 5. If those are my vertices, what do I instantly know about my ellipse? The major axis is vertical. What did you say, Blake? It will cross the x-axis, the major axis will. If you have a vertical major axis, then you know which equation to use for the ellipse, right? X minus h squared over b squared plus y minus k squared over a squared equals 1. If it's a vertical major axis, you're going to put your a underneath y. Okay, so that gets me somewhere. I might also sketch out the other things that I know. I kind of stopped there. Endpoints of the minor axis are at 6, -2, and -4, -2. So those are the endpoints of what we're calling the minor axis. The minor axis is the one that goes to my co-vertices, right? Okay, so if I want to label those, I know those are co-vertices. And that makes sense. My vertical major axis, it's longer vertically than it is horizontally. Can you get any other information besides which equation to use from the drawing that you have? Have a quick chat in your groups. What kind of information could you get from those 4 points you just plotted? Do it real quick. See what we can come up with. Allie, do you have any information for us? Nothing? Maybe drawing the ellipse too. Just kind of like get the full picture there. Is there anything that you can find instantly if you know those 4 points? Blake, you want to help Allie out? What are you going to look for? You can find the center point. Yeah. See, the center point will be at the intersection of the major and the minor axes. So one thing you can do if you have both your vertices and your co-vertices is sketch those axes. Okay. And then you have a center point right there. You should be able to identify where that center point is. The center is at, looks like 1, -2. Okay. Catherine, is there anything else you can find?
Can you just get the center from your points? Because both, like the vertices, both of the axes have the same line and then the vertices have the same line.
Yes. I'm glad you picked up on that. That's a pattern people will start to notice. Okay, the like vertices and the co-vertices, they're going to pick up. They're going to have like the same x coordinate, and then the co-vertices would have the same y coordinate, or vice versa, depending on your major and minor axis. Okay, excellent. I like that a lot. Kirsten, anything else you can find in that ellipse?
I just got the center.
You just got the center. What will the center help you find? Other things that the center does for you. Think about that ellipse homework that you did over the weekend. What'd you do after you plotted your center point?
I was here.
But you did the ellipse assignment. The ellipse.
Thursday?
Yeah. What'd you do after you plotted a center point?
Remember?
Carrie, what'd you do after you plot a center point?
Find A and B.
You find A and B. Could you find A and B now in this picture? Yeah, A is the distance from the center to the vertex, and B is the distance from the center to the co-vertex. So a really easy thing to do is once you find that center point, just count it out. 1, 2, 3, 4, 5, 6, 7. I got A is equal to 7. And then I could count it out. 1, 2, 3, 4, 5. B is equal to 5. There's other ways for you to get those numbers. You could have got that A was 7 when we initially plotted those two vertices. The distance from the point 1, 5 to the point 1, -9, that's 14 points. And then 14 divided by 2, 7 is your value of A, right? The distance between the two vertices is going to be twice the distance of A. Okay. So you could use other methods to get those. If I have HK, A, and B, I'm ready to write my equation. I already picked it was the vertical major axis. So x minus 1 squared over 25 plus y plus 2 squared over 49 is equal to 1. So really important is kind of getting your brain to think about, like, I'm really working reverse of what I did in graphing, where in graphing I had the equation and broke the equation all down. Now I have little bits of information about the graph, and I need to connect the dots and put those things together to write the equation. So I could do 5 more examples and put you even further to sleep, which would not be very exciting. And you're not going to get a whole lot out of me doing more examples. So now you're going to work in your small groups to work through examples and check your answers with me for the remainder of the class. But kind of keep this idea. There are going to be hyperbolas and ellipses mixed together. So often if your group is struggling, sketch a graph and then try at first, if you can, to decide which equation you want to use. That'll kind of narrow things down for you, and then try to find the things that you want to plug into the equation. Okay? So I am going to have just one member from each group come up and pick up your first problem.